right, so now we really should get a little bit sweet. In our family, we have this tradition every week that we make peanut butter chocolate chip cookies. And that's just like the thing you should do, right? We make them on Sunday, we freeze them, the kids take them in their lunch all week, it's fabulous. So it's a nice tradition, my kids can all make it the recipe from heart. I highly recommend it, because then I get cookies whenever I want it, because my kids are big. And when you make peanut butter chocolate chip cookies, you really should use the correct ratio. Because if you don't have the right number of chocolate chips and the right amount of peanut butter, they just don't taste right. And so if you're making peanut butter chocolate chip cookies, and you have peanut butter in your pantry, then you have to go look and see if you have enough chocolate chips to make the correct amount of the correct ratio, the correct taste for peanut butter chocolate chip cookies. So if I need, for every 2 cups of peanut butter, for 2 cups of peanut butter, do you need more cups of chocolate chips or less cups of chocolate chips? Of course you need more cups of chocolate chips. Yum. All right, so if we're making peanut butter chocolate chip cookies, and if I have 2 cups of peanut butter, I need to have 3 cups of chocolate chips. My question is, how many cups of chocolate chips do I need if I want to make lots of cookies? I use 4 cups of peanut butter. How many cups of chocolate chips do I need? That's not hard, right? How many? You guys all know that. But what you're telling me is that if I double the number of cups of peanut butter, then I need to double the number of cups of chocolate chips. Yeah? All right, so what if I told you that I want to make cookies that need 8 cups of peanut butter? We're making lots of cookies. I should have brought some. Sorry. Next time. All right, so how many? Again, you're like, Pam, this is not really hard. Okay, that's fine. So if I double the number of cups of peanut butter, do I need to double the number of cups of chocolate chips? So now I've got 12. All right, what if I were to tell you that I want to make peanut butter chocolate chip cookies and I have 10 cups of peanut butter? How many cups of chocolate chips do I need? Don't say it out loud. Everybody thinking? How can I get 10? If I have 10 cups of peanut butter, how many cups of chocolate chips do I need? 10. What's a way? Somebody? A way. Yes, ma'am.
Take the 12 and you're adding 2 more cups of peanut butter, so you need to add 3 more cups of chocolate chips.
So if I have 12 cups, why 12? I'm looking for 10 over here. You're already at 12? Help me.
Well, you had 8.
I had 8.
And you're adding 2 more.
Oh, and if I add 2 more cups of peanut butter, that would give me
10.
The 10 cups of peanut butter? Okay.
You've got to add 2 more to 12.
So I have to add the
3 more to 12.
I need to add the corresponding cups of chocolate chips. The corresponding cups of chocolate chips need to add down here. And what is 12 plus 3? 15. A fine way to do that one. Did anybody do that another way? Let me erase this real fast. Anybody do that another way? I'm going to let everybody think for just a second before I get you other way. Letting everybody think for just a sec. Did you find that 10 in another way? Looking up there. Okay, go.
I went back to the 2, and 2 times 5 equals 10, so 3 times 5 equals 15.
So if I have 2 cups of peanut butter, and I multiply that by 5, I'd have my 10 cups, yeah? Remember, we don't know the 15 right now. So if I know that I need corresponding 3 cups, and I multiply that by 5, would I also get those 15? Very nice, proportional solution. That was fabulous. That's proportional reasoning. Fabulous, well done. Can you think of another way? I know you can. 2 more ways. Which, by the way, if I say at least 2 more ways, how many can I think of? I can think of 1. Why do I say 2 when I can think of 1? Because I never want to limit your thinking by how many I can come up with. And do you know that almost every time when I say 2 more and I can think of 1, someone comes up with 1 I hadn't thought of. So don't limit your students' thinking based on how many you can think. Always say 1 more. At least I do. I always say 1 more than I really can think of. So 2 more ways, which means I can think of 1. Anybody?
I was thinking like a ratio 2:10, like 3 would be to what? In that case, okay.
So that's exactly the same relationship we used here. Very nice. Another way? Do you have one over here, Jennifer?
2 times 10 would be 20, and then you cut that in half, that would be 10.
Oh, all right. The way I hadn't thought of. So 2 times 10, we can multiply that times 10 and get 20. So 3 times 10, we could get 30. And then if I cut that in half, 20 in half to get the 10, then I could cut the 30 in half to get, I don't know. That's not too bad. There's one I hadn't thought of. All right, there's one more I'm looking for, but since we don't have it, I'm going to go ahead and ask you another question, because a good problem string, instead of just giving it away, we'll just ask another question that will sort of nudge you there. So what if I were to ask you for 9 cups of peanut butter? How could I find 9 cups? If I had 9 cups of peanut butter, how many cups of chocolate chips? What are you dying for right now? What do you wish you had up there? Isn't there one you wish you had? You're like, oh, I wish there was. Which one? You wish there was a 1 up there. Yeah, can you find the one, the corresponding one? Can you? Some of you are looking at me. Don't look at me, look at the numbers. Can you find if I have 1 cup of peanut butter, how many cups of chocolate chips? How many?
1.5.
Yeah, did you just say, hey, well, I take that in half, then I'll take the 3 in half. Can you take half of 3? Of course you can. So is that 1.5 cups of chocolate chips? So how many for 9? Add the 8 and the 1, then I would add the corresponding 12 and the 1.5, and do I get 13.5? All right, so let me erase a little bit, and I'd like you to look and see if you see a different relationship up here between that 1.5. Do you see something that looks like 1.5 up in our list somewhere over in here? Do you see something that looks like that 1.5 up there? Does 15 sort of look like that? Now, pre-K2 teachers just went, no, those are completely different numbers in every way. And they are, in a lot of ways, they're very different, but how are they similar? Can I get from 1.5 to 15? So if I said to you, remember the question was, can I find another way to find 10? Can I go from the 2 to the 1 and then scale up? So from the 2 to the 1, I found a half. Now that I know 1 is 1.5, but I don't know the 10, I can multiply that by 10. Then I have to multiply this by 10. And what is 1.5 times 10? And this is why we don't want you to do the 0 trick, where you say, oh yeah, anything times 10 is add a 0. Because 1.5 times 10 is not 1.50. Never leave anything wrong on the board very long. Erase that. Well, that's not right? That's not correct. 1.5 times 10 is 15. All right, fabulous. What if I were to ask you for, I'm going to have to extend my ratio table over here. So we still have this 2 to 3. We're still talking about peanut butter and chocolate chips. What if I were to ask you for, let me think for just a second. I'm thinking. What if I were to ask you for 45 cups of chocolate chips? How many cups of peanut butter? What did I just change? Now I'm like, this is how many chocolate chips I have. How many cups of peanut butter do I need? Did I just sort of switch which one I was giving you? But does it switch how you're going to solve the problem?
No.
Can I go back and find, can I find 45? How do I find 45 cups of chocolate chips? What's a way? There's lots of different ones. Oh, I could add, is there a 20 and 10? Help me. I don't see a 20 and 10 over here. Oh, you mean, you know what, I've got too much gunk up here. Hang on just a second. Go away, gunk. You're telling me that if I had 15 and 30, that's 45. So therefore I would add the corresponding number of cups of peanut butter, and so that is 30. Very nice. One more way. Oh, we don't have the 3 over there. I was looking for the 3 in the peanut butter, and the 3 would have been 4.5, and then we could have upped it to 4. So what you just did, everybody in this room, was successfully solve many proportions. Many non-unit proportions. And I said that for the middle school people's benefit because yesterday we solved a lot of unit proportions, unit rate proportions, and we just solved a lot of non-unit rates. You guys just did solving proportions without cross-multiplying and dividing, which is sort of the trick that we usually teach kids to memorize. But my point is we can reason through ratios. So this is called a ratio table, and these are all, we have a lot of ratios up here. And I don't know if you remember, but on that list of interpretations of fractions, remember we had 5 meanings of fractions? One of them is about ratios. And if we start with that multiplicative ratio idea, part whole takes care of itself. So it's another reason to really think about mathematics and figure through mathematics, because indeed we can.